Donna, and I think, oh, there we go. So I think we will hold questions for the end, if
Yeah,
that's okay.
indeed. Yeah.
Okay. All right. So Donna started the recording. So let's get started. Uh, I was
Oh,
kind of hoping we would have a little slide up here to let you know what today's all about, but that's
well,
fine.
it'll come in the main my main talk. I have one anyhow. Yeah. Yeah.
That's perfect.
Yeah.
Jim has come to my rescue, so thank you.
Yeah.
I'll just say this. That I'm Wendy Martinez. I am one of the co-editors along with Donna Lalonde of the ASA Chance magazine. And we're really happy to have Jim Hanley here today to give us a talk that's based, I think, mostly on the article that is just being published in the latest issue of the magazine. I found it to be fascinating. And also, I guess I'm not really an officer, but I'm very involved with the ASA History of Statistics Interest Group, which, by the way, you do not have to be a member of the ASA to join it. So, check out the ASA website if you want more information on the group. Just Google it and it should come up. All right, I don't want to take up any more of Jim's time. I'm going to pass it to him. I'm so happy that he's going to introduce himself. So,
Yeah.
because he's the expert on himself, right?
Exactly. That's what I tell our students, and I ask them to do the same, break the ice with themselves in my class. It's
Exactly.
a great chance to actually learn about public speaking when you are
Yep.
the expert. Indeed, that's exactly the point.
Yep, that's a really good way to look at it. Thank
Yeah.
you. All
Yeah.
right, so I'm going to turn my camera off and my microphone off and
Yeah.
let Jim give us a
Yeah. And
entertaining talk.
it'll only be 2 minutes of bio if I don't say anything. If I interject, it could be 10, 15. So I'll try and hold my chat and just have it be pictorial. If I can.
Well, one of the things I'm always excited about with the history is learning about our professional friends and colleagues. And so the more we know about you,
Yeah. Yeah.
I'm
And it,
happy. So that's
yeah.
great.
Yeah. Exactly. So this is, yeah, my bio right from the very beginning. That's looking east, zooming in where I went to school. My house is on the left. This is the school, 1857, two-room school, two teachers, 60 students when I went. This is getting ahead of ourselves with my kids, so it's out of order. And so is this, but this was the view from my kitchen window. I had to go to boarding school because we were on an island. And to where I think my interest in history got started was here, and I'll explain at the end. And I have a small little link with a famous person that I didn't know until I came to North America for grad student. And then somebody told me, didn't you know that that address is important? And I had the same address while I was there for one semester living in the apartment in 5 Grenville Place. But it's the same one as this. It's a mess now. It's horrible, although it's being done up. But this is the man that whose apartment I lived in 100 and something years later.
I was going to ask you if that was the same bull.
It is the same Booth, exactly. The library in UCC is called after him. It's called the Booth Library. He was the first professor of mathematics at what is now UCC, but was Queen's College, Cork at the time. Yes, so I didn't know about it when I was living there. Yeah, they're doing it up
Wow.
now. It's a heritage building now. Yeah. Then I came to North America and then met the first of the most important mentor probably I had in oncology. So that was for 4 years in Buffalo. And then he brought us for 3 more years. I stayed 3 more years with him in Boston at the School of Public Health. And it was called the Sidney Farber Cancer Center at the time, Cancer Institute. And then I happened to meet somebody who said, we have a job in Montreal. I was married. I am married to a Montrealer. And so I got lucky again and then found a permanent job in Montreal where I could do more teaching and so on. And I've been there ever since. This is jumping ahead to the oldest of our kids there in the middle, who was born in the United States, along with the second one. Third and fourth ones were born here. This now is a modern version of where I grew up because in the meantime, technology moved along. And these are a couple of pictures. Again, this one is looking west again towards America, towards the first parish. The last parish in Ireland is the first parish before America. Yeah, so that's it. So that's the end of that. Um, so now let's get to the real topic, which is the talk on about two-thirds of it is about the article that's just being published in Chance, and the last third is about another piece of work. There's two pieces of work involved by these two guys, and so I'm going to talk about these, and they're two historical articles that I think today have lessons for us and surprises for us even today. And they also show a side of Ronald Fisher and his personality that very few got to see. And both of you editors are going to be very interested in the kind of peer review the second paper got today. You're going to see it today. It's quite the story. So here's the plan. The first paper in 33 removed the father's age as a significant factor in the probability of a child being affected by Down syndrome. And the second one kicked out birth order. And these two retellings have been written up now in opposite order, almost in time. But the first one was very, very interesting and has a lot of stuff in it. And the second one likewise. So what's interesting about them is that they're a mix of and I put a lot extra material, plus including the slides and the slides and the lyrics from my talk today are on this website down at the bottom. So I'll be doing at the end of this, when I get the recording, I'll be adding the video on as well. So people will have a chance to do this whenever they want and so on. Yeah. So now this is a very interesting story. It's a mix of a lot of things. In addition to the mix that I just showed there, I think the extra item in the mix is what I call statistical archaeology. And this is the archives that allowed me to tell more of a story. Yeah, I think it's going to be, we can think about how far we've come and how proud we are of our computing today, but we are starting to lose some of the basics along the way as well because we're relying on electronic computers. One of the joys of this was teaming up with a co-author from from my alma mater for the first study, and it taught me an awful lot about sufficient statistics in a way that I never learned when I did it in math stat classes at all. Um, and Unfortunately, all of this happened just about when I was ready to retire in 2023, but still, it's better to know it now than have never known it really well. And the other joy for me and for the editor of Biometrica, when we sent the paper to them, was we both felt for the conditional logistic regression paper, we both felt, and the reviewer said this, it was like the statistical equivalent of finding an unknown pharaoh's tomb. That's what the archaeology felt like to me, to be there and peering over their shoulder and so on. And it was all because of the archives that we have available online today. So now I mentioned, I hope that the topic is Down syndrome and the role of age and the role of birth order in the probability of that happening. So here is the entry from about it. And the main thing to remember is that it's a genetic disorder discovered in around the late 1950s. The presence of, there's an extra part or a full part of a third chromosome of chromosome 21. So there's, it's called trisomy 21 because there's almost 3 copies of the chromosome there instead of the usual 2. It's typically associated with physical growth delays, some characteristic facial and other features, and I would say a range of intellectual disabilities. Now, the Wikipedia page, which again is very good on this, tells a lot about the epidemiology in a very nice, compact way. I don't disparage Wikipedia at all. And you see here especially how it highlights the very key role, the large role of mother's age in the probability of a child being affected by Down syndrome. So, when did all that get figured out, and how, and who was involved? Well, I think one of the main ones that we have to thank for it today is this physician, scientist, I would call him. He was a doctor first, statistician as well, very good at numbers and the rest of it, and just a curious guy in general. So this is the man I'm talking about. He, I'd say mainly he was interested in the genetics of intellectual deficit, but he had wide-ranging interests. Very interestingly, he was a Quaker and he opposed war, and he took his family with him to Canada for the 6 years of the Second World War, and only returned to London after the war was over, just after his daughter was born. And he took up the chair of genetics at UCL because Fisher had left UCL in 1943 to go to be the professor of genetics at Cambridge. So his wife Margaret and his four children also had very notable careers. You may see some of the names there and recognize them. There's a Nobel Prize winner among them as well. So this is a real polyglot, whatever you call him, something like that. Real serious scientist. And this is the first paper of his, and I've modernized the title here because Down syndrome was not the name that was used. You'll see a little snatches of that way back when, but this is the modernized version. So, so he starts off with the tricky problem we still have today and lots of confounding, even today in working out about Tylenol, working out about everything. There's a lot of trouble in non-experimental research to work out what's the cause of what. And it was especially the case here because there's a huge correlation between the father's and the mother's age, so it's going to be very hard to separate them. And if you look at one of them alone, if you look at the curve for the father's age, you would get just about the same curve as you see for the mother's age. It's a very steep curve as well. So why is that? How can you disentangle it? And the way I like to say it now is which age is the driver and which age is the passenger? Those are words we use, passenger variables that go along, but they're not the real thing. That's what we're trying to figure out here. Now, how did he do that? Um, well, he borrowed the idea from an American geneticist, an animal geneticist, Sewell Wright, a big name in USA genetics. And he was able to show that it was the mother's age that mattered in some disorders there. And the way he was able to do it was because he used the technique of partial correlation. This was his paper was 1926. And it wasn't unusual back then. Today we would be very uncomfortable using a correlation based on between a binary variable and a quantitative variable. But it was all he had available to him in 1933, and he had the precedent from Sewell Wright. So for his material, he had 150 families he had talked to and gotten the data from in some detail. Um, and these are personal one-on-one visits and so on. He had to leave out anybody where they weren't sure whether the child, maybe if the child had died, they weren't sure whether it was affected or not. And as best we can tell, he did all of his calculations from this table here. This table has mother's age along the top, father's age along the side, and then you see at the margins you have the number of affected and non-affected children along the bottom and along the side. But right where we were expecting it, and I brought this into class, the students didn't know when you look at those numbers in the middle here, any of these numbers, you didn't know, for example, whether how many of that six here, how many of those children were affected and how many were not. You had the margins by age of the mother and age of the father, but you didn't have the whole thing. So it's quite a mess of a thing. So what did he do? So he did the correlations. He got the first correlations, which are the crude ones, which are collapsed over the other parent's age. And you see they're both quite strong, but what's most strong is that the father and mother's ages are very highly correlated. And so this is tricky, but then he used the partial correlations to show that if you eliminated the mother's age, or controlled for the mother's age, we'd say today, there was almost nothing to say. But if you controlled or eliminated the father's age, there was still a huge signal. There's still a huge relationship between the mother and Down syndrome. But these were, as I said, very, this is just the same thing again, showing you that the only data you have here are three two-dimensional marginal totals. You don't have the 3D data. Today, and this is where the students didn't like it when I brought it into class, today I said to them, make a data frame where there's 727 children, one after the other, row by row, and in each row you have whether they were affected and what their mother's age and their father's age. They didn't have that and they couldn't. But in any case, he did realize that this was a problem. They have this kind of a variable. He called it a hypothetical variable, a variable he was embarrassed to use in a correlation, the binary variable. But he says, I don't have to do that. I have a second way of doing it as well, which is quite nice and it's quite crisp. And this is a method that actually we still use today. It's turning everything around and pretending the ages were the outcome variables. So you can compare ages of cases and controls, or if you like, or the affected and the unaffected, and see what happens. So it turns away from the 0, 1 and compares two means, the two determinants, if you like, the two x's. Even though we think of the x's as fixed and the y is random, he's doing it the other way around here. So if you look first just at the data in black, if I can show you the data in black, don't look at the colors for now. We're going to look at the ages of the father, of the cases, and the father, and you see the fathers of the affected children are about 5.5 years older than the mother, and likewise the mothers are about 6 years older than the mothers of the unaffected children. So that still doesn't tell you what's going on, because it could still be either one as the culprit. So now this is what comes next, and that's so neat. And again, ignore this piece for the moment. But now look at these two things in color, and these will explain what happens. In the first equation, you can see that I have the age of the mother, and from that I'm able to get a predicted age for the father. So you put that in, and it's 39 and it's 33. So you get a difference there of about 5.5 years still. Very nice, because it lines up with the observed. So if you use the mother's age, predict the father's, and stick it in, everything lines up. If you do it in the opposite way, which is here, you take the father's age and try to predict the mother's age and put that in here, though, you still don't get a good fit with this. So that's what led Penrose to say he was pretty sure now he knows which the culprit is. It's the mother's age that's the driver, and the father's age is the passenger. So this is quite nice, and I think you could explain this to somebody without ever having to do correlations. So you could explain it, as I say, to somebody going home on the bus or in the metro or the subway this afternoon, much more easily than you can with partial correlations involving variables like that. What wasn't known, and it's not mentioned in the paper, and I only happened to find it through the archives, was this, that Penrose had written to Fisher to consult him uh, when he was about a third of the way through, and he had done 50 families already. And interestingly, it wasn't for the method he was asking, it was how do I do standard errors when we have correlated data inside of families? That was his bugaboo. What am I going to do about that? That's messy. You're the expert, Fisher. Can you tell me how to do that? So he tells them these are the preliminary data. They worked out and they stood up, and the 150 give just about the same answers. He's doing this in October of 2032, 2 days before Halloween. And but it's the second of the two blue pieces there that I want you to look at. He says, what about those variances and so on? I can't get a standard deviation or a standard error here because we have complicated data. And so I'd like your help on that. And now what I find very interesting, and it kind of corroborates what I've seen in my own life when I've consulted people or when other people consult me, and that is that very often when you go to somebody or somebody comes to you, you're kind of stuck in a rut, and the question you put to them isn't the right question. The consultant tells you later to be thinking outside the box and think differently and think better. And that's clearly what happens here. Fisher couldn't care less about the standard errors, but he said this, here, you have a problem here, but what you can do is use the predicted ages of the mother from the father and the father from whatever, and you can compare them just like I did in the colored items in the previous page, right? In the paper, you saw that. So basically what we're saying is he got this idea from Fisher. He didn't acknowledge it or anything like that, but the archives do show it. And the interesting thing is that this letter is only 2 days later. 2 days. One was a Saturday when he got the answer, and on a Monday he had an answer from Fisher. That's the kind of consultant I like to have. So now we've come up to 2014, and at this point, one of our teachers said to me, Jim, do you have a nice data set to bring into class for our data analysis class? Come in as a guest and bring a data set with you. I said, oh yeah, I have the right thing. I'll bring in that data set from the article because we had the table published, and I said the table should be enough for people to fit the models and do everything again. Well, the first problem was that the students couldn't make a data frame. So they were completely stuck. I said we should be able to fit a logistic regression or something modern, right? Because look what we have available now. You know, even 40 years later, but look at the end, 1972 is GLMs. We even have conditional logistic regression, which we'll come to in a minute. And we had discriminant analysis a couple of years after they were talking. So starting from discriminant analysis, load it, probe it, all of these things. And now surely the students will be able to run all these and see, did we learn anything new by applying new methods to old data? Or did they get the right answer in the first place or whatever? Do the answers stand up? So they had trouble. They couldn't work it out. In the end, we couldn't help them. So we never got this data set analyzed in class because we were stuck with how do you convert that table when they're mixed inside the cells. We don't know how many are each of each kind inside of the individual cells. So how are we going to do it? So I said, look, let's go back and see if we can find the family. Do they still have the records? Would they be able to look in their father's boxes and see what it is? We'd have the raw data family by child so we could do the analysis. So the oldest son wrote back to me. He says, no, I don't know where it is. You know, it's you could look in the archives. We'd looked there already, it wasn't there. So we couldn't do anything. But then he said, but I love this paper from 1933. And, you know, I came back on it later on when I was in 2007. I was 60 or 70 at the time. And it's a beautiful paper. And I wrote it up in a chapter of a book for somebody else. And it's really neat. He didn't know about the correspondence at all. Why would he? That's in boxes still in the UCL archives down in a basement somewhere. But mathematician that he was, he said to us, well, you know, of course, if you try and get solutions, like we call it Sudoku at this point, you're going to have lots of solutions that would fit the same margins. So I said, thanks, mathematician. I knew that already. I'd be happy if we could get even one solution. That would be enough for the students to get at it. So I said, okay, I'm stuck at this point. I don't know how to do it. I put it on the web. I made it a challenge. I offered some money. And even though it was up on the web, and I said, can anyone split these cells into two? And for 10 or 11 years, no luck. Until I got to give a talk 2 years ago at my old alma mater, talking after coffee with Socratic Roy, who I'm going to meet now. And he happened to be very interested in reconstructing data from marginal tables and so on. So here's Socratic now at our seminar later on that year telling us how he cracked the Sudoku problem. And he did it. First thing he had to do before he could was he had to fix a couple of errors that he found in the bottom of the table, which are embarrassing, but they were there. And they were actually in the typesetting. We figured out that, in fact, that's not the data set that Penrose worked from. He worked from another one. The typesetting must be when the errors got introduced or in sending the tables to the journal. But in any case, Socratic knew that this was like the transport problem in operations research or integer linear programming problems where you have a lot of 325 unknowns. You have to maximize some function of them. And there's about 400 constraints given by the fact that they have to add to the margins inside and at the edge. So it's a very easy problem today. It wasn't when I was introduced to this 60 years ago or 50 years ago. But now it's very easy. There's an LP program in R that can, if you give it the constraints and you give it what you want to optimize, it comes up with, no, it doesn't have one solution. It's going to give you many, many solutions. This is the first one it gave. So for the first time, we could split into red and black who was inside of each cell here. You see? So we have here, cases where there's one of each or one in five. There's various ones. Some are singletons. It's only a case or only a non-affected people in the cell. But the point is he could do this, and just by changing the order of constraints, he could get as many solutions as we want. So I was away to the races now and itching to analyze these by modern methods. Well, linear discriminant analysis is around since 1936. Logistic regression, maybe a decade or two later. And my God, did I get some surprises. Because the first one I did was linear discriminant analysis. And here it is. So, it's just a linear combination of the mother's and father's ages. And you see here the 6.16 and the 0.07, exactly what we expected. It loads on the mother's age almost entirely, so that the dividing line is almost a vertical line, and the father's age barely comes into the dividing line at all. Barely, 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 and even comes in negatively here. So fine, I said, that's good. That validates what Penrose had found. Then I said, Socratic, give me another data set, another solution. And he gave me another one, and you'll see it's different. Because here, look, for example, this is an unaffected child in this cell, even with the same margins. This is an affected child. There's several other differences here as well. But look at the coefficients. They're identical to what they were in the other data set. Even though the data set's different, the coefficients are the same. I said, oh, that's weird. Now, I don't use linear discriminant analysis a lot, so that maybe it's peculiar to that. I said, all right, but I'll try the next thing. I'll try logistic regression, what we jumped to today, right, with binary data. Now, this is one solution, one data set that he created for us. Here you can see that, yes, the father's age taken alone seems to matter, the mother's age likewise, but if you put the two together in the model, only the mother's age matters. Great. And look at the two coefficients. They're almost identical to the linear discriminant coefficients, and there's a reason why that is that I remembered afterwards. But that's fine. But again, I run another data set and another data set, and all the data sets are giving exactly the same. I made R printed out to 8 decimal places to make sure it wasn't just something small. No, they're identical. And then I started talking to Socratic, and I think he probably knew the answer, and I didn't. And that is, we were dealing with something here that I'd been told in class, oh my God, 50 years ago. But it was just in a math stat class, and it never had any meaning for me. And that was the idea of sufficient statistics. The margins that we could see and were given in those tables were sufficient to derive the statistics of the fitted parameter values for that particular model, our logistic model. And so that's the reason. So we didn't need to go through all the reconstructions at all. But Subtract said, but Jim, you know that there's a point. I said, what's the point then? He said, well, the point of having them and why you probably wanted to have the raw data was that you can check fits of models then with what's left over after you've extracted the sufficient statistics. There is data in the rest of the data set, but it involves the adequacy of the model and so on and so on. So that's the why of it. So he was able then to run the goodness of his statistics for various solutions, and they do vary from one to the other, and we've put those on the website in an appendix to the Chance paper. But of course, the sad thing is the data set that Penrose actually used, we'll never know which one of those millions of solutions it actually was. It's vanished into the mists of history and been thrown away. Because he thought, I don't know if he instinctively knew this, that publishing what he did was enough. I also checked, because I'd done logistic regression many, many times, but I'd never done the math of what summary statistics do you need if you're going to fit a very basic logistic regression where the two ages are just linear and so on. And besides the ages of the parents, which are x's and which are given anyway, you need 3 numbers. If you have these 3 numbers, plus the design matrix, you can draw the likelihood function and maximize it. All that long forgotten in my head, never really understood, I guess. Marvin Zellen said there's a difference between understanding it and owning it. Owning it means you know it and you can explain it to somebody else. And that's what it should be. Yeah. So we've put all that online now, and the chance article will be there soon as well. So this is, you guys know that this to come out in the next issue, whatever. So it was a really fun story. It left us me anyway, quite embarrassed. I was delighted first that this modern technology that could recreate data sets with so many constraints and so many unknowns, and nearly impossible for me to imagine 50 years ago. But I didn't really know the basics at all when it came to what sufficient statistics are. They were used a lot back back in the old days to save on labor. But today we don't even group the data into sufficient statistics anyway, or reduce it immediately to sufficient statistics because the computer will take so little time anyway that it's not worth their while grouping the data. So now to the second paper, and this is the one where there's even more archaeology involved here. And this is a much fancier journal, a bigger one. And this is the topic that he was more interested in than the mother's age. He wanted to be sure that he could put birth order out of it as well, that was not a factor to matter. This one, he does in this paper acknowledge Fisher and the work. And indeed, he writes a second paper after the first one's published. He writes a second paper. I call it the methods paper. And he gives great detail, page and page and page, with examples of the calculations of what you got to do to basically fit conditional logistic regression. Of course, it was a no-name model at that time, and it was a lot of work. It's a bit like the Cox model. It's the same logic as in the Cox model for the estimation of the betas and the risk sets as well. So that's the thing, yeah. But anyway, he does also say what he didn't say in the first paper, and that Fisher didn't say anything about him. There's a major problem here, effective that there's a selection issue. We selected these families, only the families that have at least one affected child. There's millions of families without any child. Shouldn't they be counted as well? Yeah, so we'll come back to that. And then this is our little piece where we said this, even though it's no name, it moves conditional logistic regression back about 40 years. There's the referencing system we were talking about before the thing. And we've put the data set on as well. So now there's no errors and there's no ambiguities about this data set. It's there for modern students to fit as they wish. Now, a number of you, I suspect, this is something when you're trying to do history, I've learned this from the editors and the referees, you're best if you could start with the present and link it to the past. If you start at the past and use their notation, you're not going to get very far because people have nothing to hang on to. So all the people in biometrics said to me, look, start and explain first what conditional logistic regression is, then go back and they'll see what you're talking about from way back then. So I did that. And so this is how we still teach it actually to our students. Every year we have the Academy Awards, and every year our students have a little game or a little contest of who's best able to predict which actor in the competition will win Best Actor, Best Actress, Best Picture, and so on. And Pardo has been doing this for about 20 years now, and he's using conditional logistic regression. He calls it conditional logit because he comes from the economics tradition where it was called in economics, and he got the Nobel Prize for it, quantitative choice behavior. They're dealing with samples that they get after people have made choices for a Toyota versus a Datsun versus whatever, or Lexus, or Volkswagen, whatever. So they're interested in who takes the metro, who takes the car, who takes the whatever. So they get samples based on their outcomes, and then look back for the antecedents of those. So it's very much in the tradition of that. Now, if I show you the data, you'll see. Well, no, I'll first tell you some of his predictors. Doesn't matter, but they're the kind of things you'd think of. But why can't we use regular logistic regression here? Because that's not all the students said. Come on, you have a binary variable, win or not. And the trouble is they're organized by set, and there has to be a winner every year. So that immediately rules out the independent Bernoullis that you have in regular. unconditional logistic regression. Any row and any column, they're all on the rows are unrelated to each other, but in the data set here, the rows are very much related to each other. So if I just show you the data first in black here, and look at the data in black, just that, nothing else first, you see in 2025 you have maybe 5 nominees in the competition. In 24 you might have a different number. Way back in 38 you might have a different number again. Doesn't much matter. The point is the black here gives you the profile of what are the x's, the predictors that you could use for predicting or for calculating a probability that somebody would win. Right? But you see here that in the y, the outcome side of it, there has to be one, a single one, and the rest have to be zeros. A single one and the other zeros. So that immediately says you can't use regular logistic regression for that. You could do it, but you'll get a much poorer answer. You have to respect the fact here that this data set, we know already, after the fact, there's only one winner. So that's what you do. And how do you fit it? Well, to fit it, you get a linear predictor. You have it as a log linear predictor then. And so this gives you 5 relative probabilities that would add up to this total. They're functions of the x's and the betas, the usual regression setup. To scale them to 1 then so that they become proper probabilities. And the log likelihood is very simple. It's just a log of the probability that the winner won, basically. That's all it is. And so it's very easy to fix and get the beta hats for it. So now in 2025, our students did this. They have the model fitted already from 20, whatever. They can add in the new data now next year. Sorry, they've added in all the data from 2025, refit the model, and then for 2026, they're going to take the model fits from the betas from 2025 and apply them to the 26 nominees. And Andrea Benedetti, who runs this course, is going to give out prizes again this year for the students that do best at predicting what's going on. Pardo still runs his own competition and publishes the predictions as well. It's a beautiful teaching example, but in fact it fits exactly with what's going on with Penrose's data, because every block here is a family, and basically where we have a winner here, I don't know what you call it. In the other case, we have an affected child in the family. Same thing. There can be, the one difference is there can be a family with 2 children affected, and that causes extra complications. So he sent this in first, very soon after the parents' ages one, sent it to the society. He had a bigger set of families now. He had 217. Most of them had only one child affected, but 7 had 2 children affected, and that makes it even more complicated. But now you editors and you guys who get letters from editors will be very interested in the next development, because we're going to see now through the archives the peer review that this paper got in 1933. Remember when I said it was submitted? November 25. 2 weeks later, Penrose got a letter from not the editor, the referee. The referee is writing directly to Penrose and says, I'm a referee for your paper. I have a lot to say, and I'm writing directly to you instead of letting it go through anonymously as extracts from the referee's report. Oh my goodness, what a change. This is an unusual, I think, unusual practice. But he considered it so important, he didn't want anything lost in transmission, and he's writing directly 6 pages to the author himself. He says, either way, he means here by confounded nuisance, he means this is a hell of a lot of work, is what he really means by that. The very next paragraph, he comes right to the point and says what's wrong with the paper at the moment. Penrose had not recognized, and it reflected in the analysis, anything about the fact that the families had to have a child in them, and so that all the proportions inside of each family of affected children are completely artificial and arbitrary. And he says, look, you chose families containing people. How do you expect those proportions then of affected and unaffected to be natural in an after-the-fact sample? You have outcome-based sampling, we'd call it today. And so that's why things are weird. But the other thing he did, now if I got this review and said, oh my God, you've got to do all this work, and he has 6 pages of how to do it, how to fit the model exactly, But he has a very encouraging other paragraph or two paragraphs that I want to quote to all you young people here. It's coming straight from Fisher's pen, and it's this. He says, look, for God's sake, guys, if you have good data, an important question, don't do a second-rate analysis. It deserves a deluxe first-rate analysis. He said it should be, if there's better ways, you can't be open to criticism because you will have critics and you will have whatever. And he says, I expect it'll still be the same answer, but you got to do the deluxe one. And here's the deluxe method how to do it. And it's basically, as I figured out later, it's conditional logistic regression. And here is the referee's report, pages 5, 6, and 7. He's explaining how you're going to have to do it and how you do the conditioning. And this is the same omega over the sum of the omegas that he's going to do here. It's basically the same, but there's an extra complication here compared to Pardo's Oscar's data. You could have two children affected, and then it's like ties for those of you who do the Cox regression. If there's two events in a risk set, you have complications of the ties. And this is basically Fisher telling Penrose this in 1933.
Hey,
So
Jim, can I interrupt?
absolutely.
Yeah. So who do you know who hand wrote that in? Was that Fisher or Penrose?
Yes, the typist typed it, and this is Fisher's handwriting.
Interesting.
Yes, you'll see in a minute some more of his handwriting. You'll see it in a minute. Yeah. But you know, you guys are all obviously too young. We were still doing this in 1970 because our word processing wasn't very good. The typist would sit and you'd say, leave so much space where I can write the equations in. Yeah, and I'm pretty sure I don't think it's the secretary. You'll see in a minute the way he wrote things. It's very much Fisher's handwriting. Yeah. And then you'd have a carbon copy, of course, as well, and then you'd have it in both. You'd have to make both carbon copy and the original in handwriting as well. Yeah, so that's the way things happened. You'll see other reviews in a minute where nothing is typed, it's only handwritten. Yeah, Fisher had a secretary. Yeah, yeah, but yeah, so that's it. So now here comes the revised manuscript, and this was November, I think. Yeah, he got the letter. He had the revised manuscript into the journal by May of 1934. Yeah, so 5, 6 months. But those were the toughest you would never know this, but I found in the archives, and you'll see it now, there was 6 months of slog of work, manual work, because the main thing in Fisher's thing is unlike you see, when I had the data set about the parents' ages, I don't even know which children are in the same family. That's a major problem. To do the conditioning right, you've got to know how many and what ages in each family separately. So the calculations involve doing this for every single family, adding them up and looking at the fit, and then revising and so on and so on, and updating. So it's major work, and the two of them were involved. You'll see in the correspondence, the two of them, there's about 10 or 20 letters back and forth, and they met a couple of times. And near the end, they even decide, will we do another iteration? And then Fisher inverted a matrix for him as well at the end because he had the equipment to do that. Yeah. So it's a major piece of collaboration. So the revised manuscript goes in, and it's telling now what Fisher said to do. And it's kind of hard to explain in black here what these are his words, but I've put it in red in my own writing. What he did is he fitted a model based only on age. Okay? Then he took the predictions from that and grouped them by birth order. It's a bit like we kind of do in Hosburn-Lemishow tests, I think, but there I think we group the predictions themselves by quintiles or something. Here he's grouping the predictions by a variable that's not in the model, and then to see how they do. Yeah, and you'll see it better in this table here, which I have in the biometric piece. Look at the first, you see? You have 224 cases. Excuse me. These are when you group them by birth order. These are the numbers observed. These expecteds, they call them, I don't know if you call them expected or observed or calculated. I think they used to say calculated in those days for fitted. But these expectations or these frequencies are based only on the age-only model. So he's basically saying, look, if the age-only model predicts what's happening by birth rank, then we're nearly finished. Look, these are small differences. relative to their standard errors. And so he says that all of these are within not even a standard error away from zero. So it's not ideal today. I don't think you guys would accept this as analysis today, but it was a very good start for back in 1934, right? So the hardest part, the whole methods paper for me to understand, I actually gave up. I couldn't understand all the algebra and all the stuff Fisher was telling me in the email, the letters, was I couldn't figure it out. So I re-simulated myself. It's very complicated to fit these because you're fitting standard errors for something that's already constrained by the fitting of the first age model. So it's mighty messy. But they got it right, as best my simulations can say. So it's really quite something. This was 4 or 5 months of slog. Now I'm going to show you in the next slide how he fitted the age-only model. And you remember the curve from Wikipedia? It's a fairly steep curve. It's not something I think I'd want students today to just put age in linearly. It mightn't be enough. You might need extra powers and so on because it goes up very quickly after 35. But he said, look, we'll divide it up and we make it a categorical variable, 7 categories. So we basically you have 6 free parameters. And because you have 6 free parameters, there's no seventh because that's all the others are relative to one of the categories. And we're going to pick the lowest risk category in the data set as the category. So now you'll see the data set where he does the fitting. And again, stick to the part in black, or there's a black box around the data. Don't look past that at the moment. Just look here at what's going on. So we have the maternal ages, 7 categories. These are the raw data, observed data, unaffected, affected, unaffected, affected, all the way to the end. You see already what Fisher's saying. These are very weird proportions, but because they're distorted from the outcome-based sampling. So then he starts iterating what he's going to do. You know the e to the beta x's I was showing you in the Oscars example? These are the e to the beta x's, basically. But since x is 0 or 1, they're e to the betas, effectively. They're like odds, relative probabilities. So these are relative probabilities here. He left them first as raw numbers, 80, 30, 19 is the lowest, 33, and it goes up to 400. They're much better if you scale them so that this becomes the lowest risk and this becomes the highest risk. And it shows a gradient of 20 as you go from the lowest risk to the highest risk age category, only 20. This is kind of random small things here. I don't put a lot of faith in that. But the point is, now look at this calculated number of affected children. That's fitted actually by these parameters. If you give these parameter values and you fit, you get not a great fit. We would say that's not bad. 13 and 16, 14 and 19, they're not great. They're not awful, but they're off. And these are off as well. They're off by systematically serious amounts. And he says, that's not very good, but now I can improve on my betas, e to the betas, which these are, or the scaled version, which is starting at 1, relative probabilities. And I can they did 7 iterations. It took them a couple of months. And they got to a much better set of weights, 20, 10, 6, all the way up to 600. And the reason he was using 3-digit numbers for the weights is he didn't want to have decimals. So he says, let's just use 3-digit numbers, that avoids decimals. But when I scale them, the now fitted model has a relative probability of 1 here, whatever that is. We can't have an absolute because we don't have absolute data. But now we have a gradient of 90, which is much more what was in line with the data. And this is also in line with data from populations, where you study everybody. And now look at the fit. The fit now is almost 3, almost 13, almost 14, but it would have taken them about 20 or 30 more iterations to get close enough. They decided they would stop when the fitted values here were within 1% of the observed values. That's how hard computing was, because it means going back and putting these in, revising, doing a new set of calculations for 217 families again with a lot of math. Yeah, so this is the final fitted values from C-Logit today, which is the conditional logistic regression program. And if you do that, the fit, you can get the observed to be 3 and the fitted to be 3.00000, as many decimals as you want. And it takes 5 milliseconds. But anyway, that's what they did. They never mentioned that this is maximum likelihood or anything like that. But in the biometric paper, I showed that in fact it is maximum likelihood. But they were basically using the idea of estimating equations. And even in normal logistic regression, you have this idea that if you want to get the betas and you know when you're at the maximum, there's like normal equations for this, and that is that the observed number of cases must equal the fitted number of cases. The observed number of cases must equal the fitted number of cases. So as long as you keep fooling with your weights, all you got to do is keep at it until the fitted and observed agree. So we would think today of Newton-Raphson or lots of other fancy ways of doing it, but they didn't. They went straight by kind of a blind, not a great search, but they were improving every time they did it. But it's a pity they didn't have R and things like that, and they could have done so much more work if they had. But anyway, this is all in the paper, short paper, plus in the appendices. I go into all the details of it, and it's very like fitting the Cox model today. In fact, this C-logit is borrowed from the Cox model, I think, in the biostat literature. The economics people have their own logit program. Yeah. And then he gave then he got still left them as scaled probability or unscaled probabilities. But if you think of this as the lowest one, then these are all the others relative to that. That's the one where there's a gradient of about 100 in the relative probabilities. And he's make sure that they're relative because we don't have absolute because we're sampling in an odd way. So there is the other thing in journals back then, even printed journals, they were very happy to print the raw data. And so he has 7 pages here where he lists the data family by family here. And then you know the ages of each child and you know which birth order they were in. And he used a bold face to say which was the affected child. So it's a very compact way, 7 pages, to show you 210 families with all the data in them. This is what I call the head of the data set, and there's a tail function if you're an R person, and here's the last 217 one. There's actually 2 affected children here in this one. Yeah, so that's one of the doubles. Yeah, so we did a little better than that. We took this data set and I've made it into a traditional long file today that's available as a CSV file on the web. And that has every child as a single row. So it's expanded bigger than families, but so you have the age, the birth order, whether they're affected or not, and of course you have to have which family they belong to. So this serial number, which family they belong to, is a key piece of conditional logistic regression because all the calculations have to be done inside the family. But I did one more thing then when I had the data set. I said, look, it's very hard to see the correlation here between birth order. We kind of know it has to be there, but it's very hard to see the correlation from lines of data like this. So I took the first 44 families and made a little panel, a little graph for each of the 44 panels, each of the 44 first families. And in one page, I can put down even more than he does here, but I do it visually, and you're going to be blown away by how strong the correlation is between birth order and age. Of course, structurally, there has to be a positive correlation between birth order here and age here. I've divided it up into his 7 age categories and his 5 categories, birth order categories. But look, could you imagine getting data like this, where the 2 X's are so highly correlated, they're like on a knife edge, right? I mean, this reminds me of ridge regression or worse than that. There's basically no support for the separate variables. They're almost so correlated or so multicollinear, I guess, that it's hard to believe that he was able to learn anything from them. But this is a much faster way to show people that indeed the affected children do tend to be the end of the family. But in retrospect now, those standard errors for the discrepancies were fairly large. I say in the biometric paper, there isn't an awful lot of information here to be able to separate cleanly birth order from um, maternal age. What is very nice, though, is Mantell and Stark, way back in the 60s, I think, have a complete population database from Michigan, I think. Didn't have time to look it up. And there you can see in the raw data with no selection, the entire population data, you can see the exact same thing that if you condition on age, birth order doesn't matter. But it's a tough numerical data problem. So now, remember I said we got a little bit of a glimpse into the, what do you call it, peer review in 1933. They worked for 6, 7 months, 4 or 5 months. And then I didn't know until this week. I asked ChatGPT, do you happen to have a photograph? Is there any photograph of Penrose and Fisher together? They should have been because they weren't that far apart. One was in London, one was in Cambridge at the end of their days. Surely there's a picture somewhere in the archives of. Anyway, ChatGPT couldn't find any. I'm still going to look more because I have a picture of Fisher and Student together that I found in Fisher's archives in Adelaide in Australia. But ChatGPT, to give it its due, says, but I did find this. And you guys, look at this. Referee's report from the Royal Society, May 1934. So this is the referee's report on the revision. Okay? First question. Should the paper be read before the society? Yes. It should be published by the society, yes. In which of its journals? In the proceedings. Should it be published in full and in part? In full. This is Fisher's writing, by the way. Are there any material modifications necessary? And Fisher writes, this paper has been reworked so as to meet quite fully the criticism previously made. Signature R.A. Fisher. And again, you editors, this is how you're supposed to do it back in 1934. You're supposed to write any further comments to be written on a foolscap paper, on extra paper and sent in with the review. But Fisher broke all the rules of the society. Can I do this here? I know. I'll have to read it to you here what it says. It says, it's the invariable practice of the society's officers in correspondence with the author or the communicator to preserve the anonymity of a referee. But however, they can write stuff and so on, and we'll pass it on. And if there are parts that you don't want passed on, you put it in square brackets. That's how refereeing was done in 1934. It turns out that looking it up again today, I got this yesterday or the day before. Looking it up yesterday, I found out that the Royal Society is publishing now all the reviews from all the papers back then. And there's several of Fisher's and several where he was a reviewer. They're cleaning out, I guess, the boxes and putting them online. And I guess there's a statute of limitations somewhere with reviewers' comments. And so it's quite an interesting story. I suspect it's unusual what happened, but I think Fisher thought it was important enough to go right to the and it was a highly statistical paper, and there probably weren't many highly statistical people in the editorial side at that point. So it was very important that he went there. So now to wrap up, one last thing on Fisher got, I think at my count, about 9 or 10 honorary degrees. Penrose got 4. And the first one was actually from our university at McGill University in Montreal. There was a conference of genetics in August of 1958, and Penrose was awarded an honorary Doctor of Science from McGill back then. Here's a picture on the right-hand side, our principal, 2 others. Then Penrose is here. This is Penrose. And right beside Penrose is the organizer of the conference and the animal geneticist who did partial correlations in 1926, Sewell Wright, a very hallowed name in American genetics. And then the human geneticists from Cambridge at this point. Yeah, and the other beautiful thing in Penrose's personality is he wrote diaries, kept diaries of his trips. He did a 2-month trip to North America before the conference. The conference was in August. He came over early in the summer by boat with his wife and his daughter, who was 13, and toured around Canada. And he called it the North American Tour. And then I think went out through Canada on the train, drove back from Seattle and various places, visited all the friends, visited people in Ontario he'd spent the war times with, and so on, and has a lot of very fun comments about family life, but also colleagues, pain in the necks in the conference, all sorts of fun stuff. I don't think he ever thought it would be out in public now, all these years later, but it is, and it's delightful reading for people. So that's that. Then he has a second diary entry, another 18 pages that he wrote in 1964, where he came again to, this time just to the US, with his wife only at this point. And they were coming to get an award from this foundation, the Kennedy Foundation. Um, it was an international award for his work on mental, they called it mental retardation then, they called it intellectual, if, not sure what they call it now. I think it's mainly disability and mental disability, something like that. Uh, but anyway, it's a very interesting piece as well. The Kennedys set up this foundation because Joseph P. Kennedy, the oldest son of the older Joseph, the ambassador, was killed in a plane crash, and in honor of him, they set up this to fund science, investigation, research into intellectual disabilities. The award was given out because it was 1964 and Kennedy had died just before. It was given out by President Lyndon Johnson to Penrose, and this is Sergeant Shriver of the Kennedy family, married into the Kennedy family. He was the patron, I think, of the society. And the award was handed out by Lyndon Johnson himself, and there's a little speech here and a little piece in the program about research and kids and so on. Beautiful, beautiful piece. As I said, what's his name? Penrose wrote this in his diary as well, and it's 18 pages, and there's 2 pages of Penrose's diary. One about his trip over was by boat, and then he went back by plane, but he went down to see his son Roger in Texas and met several other people as well. 18 pages of delightful reading today, even. And again, being the documenter that he was, he even has a diagram he drew of how the ballroom in the Americana Hotel in New York City was set up, who was at the dais, who was here, who was there, and so on. Quite the piece, quite the piece. Beautiful reading that's on the website. You'll have to look at it. And then this one is from the very first inaugural meeting or award ceremony of the Kennedy Foundation, 1962. And the award was given by President Kennedy to the discoverer of trisomy 21. There's a little bit of controversy whether he was a Frenchman, whether he deserved it, or a woman who helped him should have gotten some of the credit as well. But there's 7 minutes of a YouTube video here that nearly made me cry to watch. But anyhow, it's there. So, and we've put this along with everything here. You have the award ceremony, you have the JFK 7 minutes, you have all the 2 diaries. It's well worth reading and being inspired by. So now I come to the wrap up, and the wrap up I think is more or less like this. First of all, for the broad findings, substantively, they've pretty well held up, although things have gotten more complicated because we now have a mix of different types of things under the umbrella of Down syndrome. So it's a mix of curves and a mix of models and so on. In some cases, the father's age matters, and some it doesn't, and some the mother's age matters. It's a much more complicated mix than we knew before the genetics were worked out. Now, I've already told you that I learned an awful lot from the 1933 paper, most importantly about how sufficient statistics really do their job, and how I should have known better than to try and go through all the work. But in any case, that's what it is. The 34 paper is about what I call a no-name model, today conditional logistic regression, fitted from first principles, but actually with almost no derivation until I worked it out myself. But it gives many, many insights and connects many, many dots with a lot of other models today and with a lot of inference procedures as well. So that's that. Now, I always say there's 2 types of models. There's the ones we always fight about, the mathematical, statistical kind of models that we worry about the fit and all the other stuff that goes on with modeling today. But there's another one, and I've alluded to it already a little bit in my bio, and it's what I call the human model. there's a statistical models who are human. And I mentioned two of them already. Marvin Zellen and Fred Mosteller were two of mine. And the trouble is that the idea statistical model for a person, that title has already been taken. And if you click on this link here, it'll actually bring you to the book that the Harvard graduates wrote about their model, Fred Mosteller, when he turned 70. But I think it's very important to still have statistical models that we can study and emulate. I wouldn't recommend for reading to read Fisher's writing. It's too cryptic. He does everything is self-evident. But Penrose's writing is really good. He lays it out nice, and you can follow it and see what he's doing. The one extra thing I think in Fisher as a model is that he's got bad press from a lot of people about his personality, and I think it's undeserved. He was not as brusque and as what's the word we'd use today about him? High strung and had enemies and so on. He respected people and he respected work, and he is a guy now. After reading all this, I would love to go out for a beer with. I wouldn't go out for a beer with Pearson or any of those. I'd go out with Penrose, and I'd have gone out with Student. But the generosity that I see behind the scenes here, and he didn't want to be an author either on this, but he encouraged Penrose to write it up separately. So I think for his generosity to his younger colleagues, he was excellent. As was Mosteller and Zellen and all the others that I was lucky enough to have as a mentor. And then a message for all the young people listening. I think you guys think of history and archaeology as for old fogies like me, but that's fine. But today you have the internet, you have online stuff. Don't have to go to archives. The stuff is online and it's instructive and inspiring. And you learn a lot from seeing how people stumbled to get the methods we have today. Now, lastly, I just want to thank people kind of in order from today backwards. This is only 2 days ago. I got this from ChatGPT. Uh, the archives at UCL, and I needed, for some of it, I needed the carbon copy was in Adelaide, so I needed the two archives to be able to fill in the whole story in the case of Penrose and Fisher in the first case, because stuff was missing in one. Then I was very, very lucky to just by chance at coffee talk about the Sudoku problem we had with Socratic at UCC. And, that's the one thing I think that's gone with the Zoom is that these after the coffee, after the seminars, no longer happen. And I'm afraid the serendipity from that isn't there anymore to the same extent, but I encourage it. Andrea brought me into the class in 2014. That's what got me interested in these data sets in the first place. I had a lot of colleagues, great colleagues over the years, and I've mentioned the great mentors I've had, Mosteller, and let me make sure, Marvin Zellen, Fred Mosteller, Barbara McNeil in Boston, and Morris McGregor here you won't know, but those are the four I considered that I was so lucky to have. And then the one most of all that I think got me interested in history is my professor in Cork when there was only four of us in the class. And this guy said, he said to us something. He said, we were interested in the journals. He said, yeah, but you guys are too young still to look at the journals. They're very spicy and they're risque, and there's a lot of nasty fights between Fisher and Pearson, and Naaman Pearson, all that stuff is very ugly. You guys are too young for that. And he used to keep the journals in a locked cabinet behind in his office. They weren't even in the library. They were in his own personal copy in the thing. But I think anytime you ask young people you were too young and well, put it in the locked cabinet, that usually brings out the inquisitiveness and the curiosity in at least some of us. And I think that's what I thank for getting me started on this whole statistical history journey. So that's it. Stay tuned. That's it. I don't know what time we're at, but that's the total.
That was amazing. Thank you so much. Do you have time for just two questions, maybe two-ish questions?
Sure, I didn't realize I've gone over time. I rehearsed this 5 times and I was always under 45 minutes.
No,
I'm
it's
sorry.
no problem.
Yeah,
We
sure.
still have people listening. If nothing else, we have a recording.
That's it.
And
We have the recording and we have the online website. Yes, go
yeah.
ahead with your question.
Yeah, so one person asked about, this is going back to the 1933 paper,
Yeah,
asked about semi-partial correlation.
I don't even know what that is. I'm old enough to be able to admit I don't know what it means.
Sounds like a possible another investigation paper.
Yeah, have the person write to me and get me up to speed. Yes, I didn't know. Absolutely. Yeah.
Yeah, that would
Yeah.
be
Oh, I think there is one that we did something in the appendix that's online for the chance paper. All of the stuff that Socratic did was model based, and all the goodness of fit statistics were model based. I did some where I didn't fit a model and tried to come with the various solutions I came up with, maybe semi-parametric ones. I don't know if it's a correlation or not, so they might want to look there, but get in touch with me if they can. Yes.
okay, that would be great. Thank you. And the second question, oh gosh, now I gotta find it. Oh, why did Fisher not want to be an author on the second paper, the 1934 paper?
Well, I think first of all, he was a referee.
Oh, yeah.
Maybe he didn't want that known. He broke all the rules. I mean, it would have been really weird to be an author and a referee, although it's happened, I'm sure, in cases, but it would have been tricky. He was that type. I've heard from others since, and seen Edwards and all the others. He was very good to young colleagues. He was just very generous to good colleagues. And he did this to many people, apparently, and it's not well known. Yeah, but now we know it through the archives. I'm going to look at some more of his referee pieces now to see what happened to them. But yes, he was that type. He was that type. He was known to be prickly and have a thin skin, but they said for people, young people, that he was tougher, I think, with his peers, like Pearson and those, that was different. But for the young people, he was most encouraging and never could give enough. Yeah, yeah.
Well,
And did
I could probably calculate it. I'd have to go figure it out. But what
yeah.
was the age difference between, I mean, how much
Uh,
younger was Penrose?
Fisher was born in 1890, and he died at age 72 in 1962. So that's a bit of it. Penrose was born in this century, I think, wasn't he? I can't remember now. I'd have to go back and look at
Oh,
it.
so maybe
I
10,
think
20
I
years.
think 10, 15 years. Yeah,
Yeah,
yeah. They
okay.
succeed, but they succeeded each other at UCL, indeed. Yes, and that's a whole other story. Steve Stigler has been into our correspondence there about should Penrose get the job, and they split the job actually at UCL because it was the Galton professorship, and it's a very interesting that in the award ceremony at the Kennedy Center, he's written still and he's the Galton professor of eugenics.
I
Uh,
noticed that.
did you? Well, what has
Yeah.
happened, Stephen Stigler and Edwards and Cambridge would tell you that he had been trying for many, many years to get eugenics out of it. And he got the word "eu" out of the journal as well. But the conditions of the bequest from Galton is the one who gave the money for the professorship. And so legally, he was appointed as the professor of eugenics back in 19 whatever, the first, chair or whatever. So that's what made some of the legal problems. But everything I've read about it, yeah, about well, Pearson and Fisher, but especially Penrose, I mean, Penrose did try as much. Gradually, he took the word eugenics off the notepaper for the department, the letterhead of the department. He did everything he could, and yet he's getting bad press still from some of the people who'd like to cancel him as well. And of all the people that shouldn't be cancelled, Penrose is one, and Fisher probably would be two, in my mind and in the minds of anybody who's looked at the data. Neither of them should be canceled, but that's another day for another story.
Yeah, and did I understand you correctly that uh, when Fisher sent the referee report,
Yeah.
that after that, then Fisher and Penrose worked together on the calculations?
Well, they had been no, no. They worked between November 33 and May 34 to finish the paper. The paper went in, then pro forma, Fisher said it's fine, it's been reworked. By that time, when he was writing the thing, everything was done and finished. And the paper was accepted that day and published, I think, in August. Meanwhile, he had to rewrite the paper for the methods one.
Mm.
And very interesting in that paper, that's the Annals of Eugenics or Annals of something, I forget what it's called. That's a paper, a journal that Fisher inherited from Pearson. Anybody who was at UCL and had that chair, there was a journal that went with that job, being editor of it. It was an internal journal run by that department. And you had complete freedom to publish whatever you wanted in it. So I see no review of that. The methods paper is published right away. And Fisher had just taken over that summer or that year. He'd taken over at UCL from Pearson Senior, and he had inherited the journal, the journal where he put the methods paper. So a lot of strange connections. Yes.
Very interesting. I think we have one last question or statement.
Hmm.
Sorry, I got to try to read it. The interest of the Kennedy family in intellectual
Oh,
disabilities.
yeah, we know why that is, huh?
Oh,
Yeah.
yeah.
Did he explain that, or the person explain that?
It
What?
was related to Rosemary.
That's right. She, the sister. Yes, yes. And wait till you hear.
Oh gosh. Okay. Yeah.
Yeah, wait till you hear Kennedy talking about it. It's quite, he doesn't say her name, but he talked about people who lived in the shadows. It's a beautiful tribute, Kennedy's piece to science.
Well, I love the quote from of Kennedy. It was on the lower right
Yes,
corner.
yes, yes,
Uh,
yes. But
wow.
he,
Very.
yeah, he explains. I'll put it on the video, I think now, just to have it on the record. He explains when he was giving the award in 62 to the guy who figured out the trisomy 21. He explains in about 5 minutes why mental health and why research matters. And he gives the examples of two kids, two sisters, one who was 8 and one who was 6, who were in the White House with him the year before. The older child is already retarded, and he uses that word. The younger sister, who was born with exactly the same genetic problems, is perfectly fine. And the reason is, and he doesn't say what the disorder is, but I think it's PKU.
Mm.
PKU is something you can test for at birth, and if you don't treat it right away with diet, the child becomes retarded. That's the genetics of PKU and the downside of it. But if you can get it within a couple of weeks or months and change the diet, it's in my family. And I have a niece who's perfectly fine. So he talked about just a 2 year difference. The research came out and Penrose was involved in modifying the diet of these people so they could something to do with phenylketonuria. It says the name. Special diet that you have to do, very restrictive diet, but it means you won't be mentally retarded after 3 or 4 years of neglect if you don't take it. So please, everybody, watch Kennedy explaining that in 5 minutes in the most beautiful language.
Wow. I will definitely do that.
Yeah.
Okay. Well, we've taken up enough of your time. Thank you so much. And if we ever have the pleasure of
Yeah.
seeing each
That's it.
other in person, I
Yes.
will buy you
Yeah.
that cup of coffee.
That's fine. And I'd be very interested as I show you more, as I find more about the reviewing process to send you what I see, find.
Yes, I'm going to try to check out the RSS.
Yes. Yeah. Yeah. Yeah.
Is that link there? The link?
I'll send it to you. No,
Okay.
it is kind of, but it's a long link, and I'll send it to you again. Yeah.
Okay, thank you, because that would be fascinating. Oh, and I'll just end with
Sorry.
one
Yeah.
thing is
Yeah.
that I really loved how you kind of discovered sufficient statistics, or because you're right, you hear in a stats course it's
Yeah.
sufficient statistics, but
Yeah.
what's
Yeah.
that really mean?
Yes,
So you
exactly.
showed this is what it really means.
Exactly, but
Uh,
we'd never know today because it's just math stat. Yeah, that's it. It doesn't mean a
yeah, it's
thing.
just something you
But
sort of show
it
or
made a
whatever.
big difference when you see the idea of data reduction mattered in those days. Now it doesn't. Nobody reduces data. They let just or burn extra electricity fitting the model.
Exactly. Yes.
Good.
All right. Well,
Yeah.
thank you so much.
Thank you. Thank you.
And thanks
Yeah.
everybody for
Yeah.
sticking with us,
Yeah.
and keep an eye out for our future chance and history webinars. So thank
Thank
you again, Jim.
thank you, guys. Yeah.
All
Bye-bye.
right. Take care. Bye, everybody.